What is the Big Bang? The Big Bang theory is the leading explanation for how the universe began. Simply put, it says the universe as we know it started with an infinitely hot and dense single point that inflated and stretched, first at unimaginable speeds, and then at a more measurable rate, over the next 13.7 billion years to the still expanding cosmos that we know today. Existing technology doesn't yet allow astronomers to literally peer back at the universe's birth. Much of what we understand about the Big Bang comes from mathematical formulas and models. Astronomers can, however, see the echo of the expansion through a phenomenon known as the cosmic microwave background. While the majority of the astronomical community accepts the theory, there are some theorists who have alternative explanations besides the Big Bang, such as eternal inflation or an oscillating universe. Around 13.7 billion years ago, everything in the entire universe was condensed in an infinitesimally small singularity, a point of infinite denseness and heat. Suddenly, an explosive expansion began, ballooning our universe outwards faster than the speed of light. This was a period of cosmic inflation that lasted mere fractions of a second, about 10 to the power of 32 of a second, according to physicist Alan Gough's 1980 theory that changed the way we think about the Big Bang forever. When cosmic inflation came to a sudden and still mysterious end, the more classic descriptions of the Big Bang took hold. A flood of matter and radiation, known as reheating, began populating our universe with the stuff we know today: particles, atoms, the stuff that would become stars and galaxies and so on. This all happened within just the first second after the universe began, when the temperature of everything was still insanely hot, at about 10 billion degrees Fahrenheit, 5.5 billion Celsius, according to NASA. The cosmos now contained a vast array of fundamental particles such as neutrons, electrons and protons, the raw materials that would become the building blocks for everything that exists today. This early soup would have been impossible to actually see because it couldn't hold visible light. The free electrons would have caused light, photons, to scatter the way sunlight scatters from the water droplets in clouds, NASA stated. Over time, however, these free electrons met up with nuclei and created neutral atoms or atoms with equal positive and negative electric charges. This allowed light to finally shine through, about 380,000 years after the Big Bang. Sometimes called the afterglow of the Big Bang, this light is more properly known as the cosmic microwave background, CMB. It was first predicted by Ralph Alpher and other scientists in 1948 but was found only by accident almost 20 years later. This accidental discovery happened when Arno Penzias and Robert Wilson, both of Bell Telephone Laboratories in New Jersey, were building a radio receiver in 1965 and picked up higher than expected temperatures, according to a NASA article. At first, they thought the anomaly was due to pigeons trying to roost inside the antenna and their waste, but they cleaned up the mess and killed the pigeons and the anomaly persisted. Simultaneously, a Princeton University team led by Robert Dick was trying to find evidence of the CMB and realized that Penzias and Wilson had stumbled upon it with their strange observations. The two groups each published papers in the Astrophysical Journal in 1965. For more video like this, visit and subscribe our channel.